what do you mean by A cross B? A cross B is nothing but pairing the elements of A with respect to B and writing it in the form of an ordered pair. The first element should be equal to the first element and second element should be equal to the second element. Then only we say that the ordered pairs are equal. When I am pairing or when I am writing the Cartesian product of the same set, here the first element and the second element belongs to the same set. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So today we are in the chapter Relations and Functions, and in this session we are supposed to learn what is Cartesian product of two sets. Now let's see the Cartesian product of sets. What does it mean? Suppose we have two sets P and Q. They are non-empty sets. Let us take they are non-empty sets. Now the Cartesian product of two sets P cross Q is the set of all elements in the form of an ordered pair where the first element belongs to the set P and the second element belongs to the set Q. Suppose we take as an example, let A is a set containing two elements red and blue and B is a set containing the elements B, C, S. Then what do you mean by A cross B? A cross B is nothing but pairing the elements of A with respect to B and writing it in the form of an ordered pair. That is, we will pair the elements with red. Red comma B, red comma C, red comma S. So, and we will write it in an ordered pair. See here, red comma B, red comma C, red comma X. Next, we'll take the second element. We'll pair blue comma B, blue comma C, blue comma S. That is blue comma B, blue comma C, blue comma S. Thus, writing the two sets in the form of an ordered pair where all the first elements here you can clearly see that belongs to your first set and the second elements in the ordered pair belongs to the second set. This is nothing but your Cartesian product of any two sets. Now I said let us take P and Q as a non-empty set. What happens suppose if any one of the two set is empty? Now let me take set A is empty and set B is your BCS. Then A does not contain any element to pair with the elements of set B. That is, there are no element inside set A where we can pair with the second set B. Thus, there we call A cross B as an empty set. Cartesian product of set is also a set containing the elements in the form of an ordered pair where all the first element belongs to the first set and second element inside the ordered pair belongs to the second set. But here there are no elements to pair. That is why we call A cross B as an empty set. So that is why if either P or Q is the null set means empty set, then P cross Q will also be empty. That is why to pair any Cartesian product of any two sets, we always prefer non-empty sets. Now let us study some important points related to the Cartesian product. So two ordered pairs are equal if and only if the corresponding first elements are equal and the second elements are also equal. Suppose I take two ordered pairs. Let me take A comma B and C comma D. So when I say A comma B is equal to C comma D, this is only possible whenever A is equal to C and B is equal to D. That is, the first element should be equal to the first element and second element should be equal to the second element. Then only we say that the ordered pairs are equal. Next, if there are P elements in A and Q elements in B, then there will be PQ elements in A cross B. That is, we know that N represents the number of elements inside the set. Now suppose A contains number P elements. There are P elements in set A, Q elements in set B. Then how many elements are there in your Cartesian products? It is again in the product form P into Q. So previously I have taken an example. So N of A here it is equal to 2 and N of B here it is equal to 3. So therefore, how many elements are there in A cross B? That is, number of elements in A cross B is equal to 6. 1, 2, 3, 4, 5, 6. One ordered pair is considered as one element. So therefore, we have 2 into 3, 6 elements inside the Cartesian product. In general, if there are P elements in A, Q elements in B, then there are PQ elements in A cross B. Next, if A and B are non-empty sets, either A or B is an infinite set, then A cross B is also infinite set. For example, let me take set A as a set of natural number, that is 1, 2, 3, 4, etc. And let me take set B as containing two elements A comma B. Then how A cross B? We can clearly see here A cross B. We need to start with element 1, 1 comma A, 1 comma B. 2 comma A, 2 comma B, 3 comma A, 3 comma B, 4 comma A, 4 comma B, 5 comma A, 5 comma B, and it is infinite. So therefore, if any one of the set is infinite, then your A cross B is also an infinite set. Next thing is A cross A, that is the Cartesian product of the same set thrice is called as the ordered triplet, and it is always defined in the form of A comma B comma C. So here 3 elements are written inside the triplet form. So and all the elements A, B, C belongs to the same set. So whenever we have A cross A, the Cartesian product of the same set 3 times is nothing but your ordered triplet, where all the elements A comma B comma C, that is the first element, second element and the third element, belongs to the same set, and it is called as ordered triplet. So we have a question here. If x plus 1, y minus 2 is equal to 3 comma 1, find the values of x and y. So I said two ordered pairs are equal when first element is equal to the first element and the second element is equal to the second element. So by using that property, we can find the values of x and y here. So therefore, I can write x plus 1 is equal to 3 and y minus 2 is equal to 1. So therefore, we will get x is equal to 2 and y is equal to 3. Next question. If x by 3 plus 1, y minus 2 by 3 is equal to 5 by 3, 1 by 3, find the values of x and y. So again, using the same concept, we can take x plus 3 plus 1 is equal to 5 by 3. First element to first, second element to second. So here we can write y minus 2 by 3 is equal to 1 by 3. Let us solve this. We will get x plus 3 by 3 is equal to 5 by 3. 3 cancels. X is equal to 5 minus 3. X is equal to 2 is the value of x. And here we can shift 2 by 3 to the right hand side. We will get plus 2 by 3, which can be written as 3 by 3. So cancelling this, we will get y is equal to 1. Next question. If P is equal to A, B, C, Q is equal to R, form the sets P cross Q and Q cross P. Are these two products equal? First, let us find what is P cross Q. That is pairing the element of P with respect to Q. Now pair A comma R. So there are no other elements. Next we can write B comma R, C comma R. So we have here 3 elements. 1 elements, 3 into 1, 3 elements in P cross Q. Now let's take Q cross P. So we need to pair the elements of Q with respect to P. We have only one element in Q, that is R. Now R is paired to A, B, C. So therefore it is equal to R comma A, R comma B, R comma C. And here the number of elements is again same. But look at the ordered pairs here. Here A comma R and here R comma A. They are not equal. So when I say two ordered pairs must be equal, first element should be same, second element should be same. But here they are not equal. So therefore clearly we can say P cross Q is not equal to Q cross P. So what does this implies? This implies Cartesian product is not commutative. It doesn't obey the law of commutative. But look at the number of elements in P cross Q and Q cross P. So it is one and the same. We have 3 elements here also. We have 3 elements here also. That is, number of elements in P cross Q is equal to number of elements in Q cross P. So the number of elements in both products are same, but they are not equal. Next question. Let A is equal to 1, 2, 3, B is equal to 3, 4, C is equal to 4, 5, 6. We need to find out the following sets. First one, A cross B intersection C. Second one, A cross B intersection A cross C. Third one, A cross B union C. Fourth one, A cross B union A cross C. So first let us find out A cross B intersection C. Now let us write set A, 1, 2, 3 cross. What is B intersection C? The common element in B as well as C is 4. So B intersection is C is 4. So because we have B intersection C as an element 4. So now pair this. How to pair? 1, 4, 2, 4, 3, 4. Now let's see the second one. For the second one, first we need A cross B, then we need A cross C. So first let us take A cross B. So set A is 1, 2, 3. Set B is 3, 4. So pairing this we will get 1, 3, 1, 4, 2, 3, 2, 4, 3, 3, 3, 4. So this is our A cross B. Now let's take A cross C. So what is A cross C? Set A is 1, 2, 3. Set C is 4, 5, 6. Now let's pair the elements. We have 1, 4, 1, 5, 1, 6, 2, 4, 2, 5, 2, 6, 3, 4, 3, 5 and 3, 6. So this is the second set. Now we need to take the intersection of these two sets. That is, we need to find the common elements in A cross B as well as A cross C. Now what are the common elements here? We can see 1, 4 is the common element. Next we have 2, 4. Next we have 3, 4. So therefore, A cross B intersection A cross C is the set containing 1, 4, 2, 4 and 3, 4. So this is the set. Now another thing you need to observe here, look at the first statement, A cross B intersection C. It is the set containing 1, 4, 2, 4 and 3, 4. And the second set, A cross B intersection A cross C. It is containing the same element. Hence, we can also conclude here that A cross B intersection C is equal to A cross B intersection A cross C. So, we can use the property of distributive to describe this relation. Let us take the third one. Now, we need B union C first. B union C is 3, 4, 5, 6. So, now here B union C along with A cross B union C. So, therefore, A cross B union C, we will get it as 1, 3, 2, 3, 3, 3. Next, we have 1, 4, 2, 4, 3, 4, 1, 5, 2, 5, 3, 5 and 1, 6, 2, 6, 3, 6. So this is the elements. So we have 3 elements here, 4 elements here. So 3 4s are 12 elements should be in the set A cross B union C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 elements inside the set A cross B union C. And we can also verify A cross B union A cross C, that is we will get the same set here also. So this is one and the same, that is A cross B union A cross C will also result with the same set. Thus we can also conclude this statement, that is A cross B union C can be equal to A cross B union A cross C. So using the property of distributive. Next question. State whether each of the following statements are true or false. If the statement is false, rewrite the given statement correctly. So the first statement says, if P is M, N and Q is N, M, then PQ or P cross Q is M, N, M. So let us write the Cartesian product of P cross Q. So first pair M with Q, we will get M, N, M, M. Next we will get N, N, M. But here they have given only two elements, therefore the given statement is false. Next we have, if A and B are non-empty sets, then A cross B is a non-empty set of ordered pair X, Y such that X belongs to A and Y belongs to B. So this can be defined as A cross B is a collection of all ordered pairs in the form of X, Y such that X belongs to A and Y belongs to B. It's a true statement because Cartesian product of two set will be written in the form of X, Y where all the first elements you can see it belongs to set B and all the second elements belongs to set Q. Similarly, X, the first elements belongs to the first set A and Y, the second element belongs to the second set B. So this is the definition of Cartesian product. Thus, this statement is a true statement. Next, if A is equal to 1, 2, B is equal to 3, 4, then A cross B intersection empty set is a empty. Now, we have here A cross B intersection empty. Now here, what is the intersection of any set with the empty set? Since empty set does not contain any elements, there is no common elements between these two sets. Therefore, we will get B intersection empty as an empty set. Now, I already told you if any one of the set is empty, then the Cartesian product of the set is also empty. So, therefore, the given statement is a true statement. Next question. If R is the set of all real numbers, what do the Cartesian product R cross R and R cross R cross R represent? Now, what does R cross R cross R represents? So, let me take the same 1, 2 cross 1, 2 cross 1, 2. So, what is the first point can be happen here? We can take the first one as 1, 1, 1, 1, 1, 1. The second one as 1, 1, 2. The next one, we can take it as 1, 2, 1, 1, 2, 2. And here again, we can take it as 2, 1, 1, 2, 1, 2. Next, we can take 2, 2, 1, 2, 2, 2. So here we have 2, 2, 2, 2 to the 4, 4 to the 8 elements in the triplet form. Now this is R cross R cross R. So what does this represents? These are the triplets which represents the point in three-dimensional plane. So let me take an example. If this is your x-axis, y-axis and z-axis. So if I take 1, 1, 1 here. So somewhere the point. So 1, 1, 1. So a point in three-dimensional plane. So therefore, R cross R represents the collection of all points in three-dimensional plane, whereas R cross R represents the point in two-dimensional plane. Next one, if A is equal to -1, 1, find A cross A. We need to find out the ordered triplet here. So let me take A cross A cross A. So first let me find out A cross A. So A cross A means I am pairing -1, 1 cross -1, 1. So let me pair this. We'll get -1, -1, -1, 1. Next we have 1, -1 and 1, 1. So now the same set, let me take it as A cross A cross A. Now these elements have to pair with minus 1 comma 1 again. So let me pair the elements. So let us pair first all these elements with minus 1. Then I'll get minus 1 minus 1 minus 1 minus 1 1 minus 1 1 minus 1 minus 1 1 comma 1 comma minus 1. Next let us pair with 1. Then I'll get minus 1 minus 1 1 minus 1 1 1 1 minus 1 1 1 1 1. So this is A cross A cross A. So now we have 2 elements here, 2 elements here, 2 elements here. The product gives you 8 elements in A cross A cross A. Next, if A is cross B is equal to A comma X, A comma Y, B comma X, B comma Y, find A and B. So according to the definition of the Cartesian product, it is nothing but collection of all those elements in the form of an ordered pair, where the first element in the ordered pair belongs to the second set and the second element belongs to the second set. Now, according to the definition, I said first element belongs to the first set. So therefore, from the given Cartesian product, we can write set A as A comma B, and second element belongs to the second set. So therefore, from the definition of the Cartesian product, again I can write set B as X and Y. Next, let A is equal to 1 comma 2 and B is equal to 3 comma 4. Write A cross B. How many subsets will A cross B have? So we have studied in the chapter sets. Suppose set has n elements. Suppose set has n elements, then number of subsets that can be formed is equal to 2 power n. Now A cross B is also a set. So first let us find out how many elements are there in A cross B. Then we can form the number of subsets in A cross B. So let us write A cross B. So pair 1 comma 2 and 3 comma 4, we will get 1 comma 3, 1 comma 4, then 2 comma 3, 2 comma 4. So clearly here, number of elements in A cross B is equal to 4. Therefore, number of subsets in A cross B is equal to 2 to the power 4, which is equal to 16. So therefore, A cross B has 16 subsets. Next, the Cartesian product A cross A has 9 elements, among which are found minus 1 comma 0 and 0 comma 1. Find the set A and the remaining elements of A cross A. So here A cross A has 9 elements. So when I say 9 elements in A cross A, that means the product of number of elements is equal to 9. So that is number of elements in set A cross number of element in set A is equal to 9. So this implies, so number of elements set A whole square is equal to 9. So therefore number of elements inside A is 3. So there are 3 elements inside the set A, and all the 3 elements from the 2 ordered pairs we can find here. So this implies set A has the elements minus 1 comma 0 comma 1, because they have given the ordered pair here. So we can have 3 elements, that is A is equal to minus 1 0 1. Then we need to find the remaining elements of A cross A. So let us write A cross A now. So A cross A means pairing the elements minus 1 0 1 with minus 1 0 1. So when I am pairing or when I am writing the Cartesian product of the same set, here the first element and the second element belongs to the same set. So therefore here we will get the ordered pairs in the form of minus 1 comma minus 1, minus 1 comma 0, minus 1 comma 1. Next we will get 0 comma minus 1, 0 comma 0, 0 comma 1. Next we will get 1 comma minus 1, 1 comma 0 and 1 comma 1. So these are the remaining elements of A cross A. So thus, this is how we are going to write the Cartesian product of the 2 sets in the form of an ordered pair. We'll meet you in the next session with the new concepts. Until then, Keep watching, keep learning, keep exploring. Thank you.